So these three equations take too long, okay? It takes me about 10 minutes to solve the distance from a point to a line, okay? So you can either continue solving this by hand, or you can use my handy program right up there to solve it for you. Now, how exactly does it work? It's pretty simple. I'm just going to go ahead and enter the point. As you can see, if you look on the paper right here, I'm using the point right here, and the line right here. And we're going to enter those. So, you can enter the point. You can have a space here or not. It doesn't matter. As long as it's in parentheses with a comma, should be good. Hit enter. Y equals. Now, in a future update, you won't have to do 1x or negative 1x. But as of right now, you do have to do that. So y equals negative 1x plus 3 is our equation here. Hit enter. And it shows all of the work for this problem, which is why you would want to use this, my solver, instead of something like this, which if you enter it, it'll show you some of the work, but it won't show you every step of the way that it took. So this will get you all the work as well as the answer to the problem. So we have an equation, a sample equation here, and we're going to solve it. If you look on the paper here, first, so you can see that this is 1.4, approximately 1.4, and so that's the answer also in the program here. So we're just going to enter to continue. Now we're going to solve this equation. Now it can't take fractions yet either, which I'll try and get those in the future update. I'm not quite sure how those will work, but they shouldn't be too hard to add. So now but for now we're going to enter negative 0.25 because that's the same as 1/4. So we're going to enter, our point is going to be negative 0.25 and then comma 5. So that's our point. And then the slope of the line is going to be, so first you will have to solve this. You can't type negative x plus 2y equals 14. So we're just going to solve this really quickly here. So our equation, once again, it's negative x plus 2y equals 14, negative x plus 2y equals 14. And this is pretty straightforward. I'm just going to add x here, add x here. So x plus 14 equals 2y, 2y, and then 1/2 x plus 7 is going to be our y value. So that's our equation, y equals 1/2 x plus 7. So now we're going to go ahead and enter it into the program. Equals 0.5 x plus 7. We're going to enter that, and our distance should be 1.7. Because we're rounding it to the nearest tenth. So 1.7, enter that, hit check, and it is correct. Now, if your teacher asks you to show your work, this is what you can do. So you'll notice here that the first step that you're going to do is find the equation of the line perpendicular. So if you look in in our program here, you're going to notice that this is the first step. This is the unsimplified equation. This is what you're going to write down first. So on a blank piece of paper, okay, take this blank piece of paper, and on this blank piece of paper, you're going to go ahead and you're going to write y minus 5 equals negative 2, and then x plus 0.25. Okay? And you can just keep kind of jotting down the work here. You know, then next you would write down y equals negative 2, x plus 4.5, and you would just keep going through here and jotting down all the work, following all the steps. You can actually look at here, but I'm sure your teacher, or if you're not a student and you're just using this, testing this out for fun, here are the equation, here are the steps you can follow. Yeah, so that's that. so it easily solved this one. Now let's say you want to solve one like this. Well, this is actually really handy because it shows all of its work. So here, write an equation of the line passing through the point P 2, 3 that is perpendicular to the line y minus 4 equals negative 2x plus 3. So here, we're going to find equation of the line that is perpendicular and passes through the point. Now we know there's going to be exactly one, right? Now, the nice thing about this program is that it shows all the work. So it's actually going to give, when you solve this to find the distance, it will also give you the perpendicular line. Okay, so we're just going to hit enter here, restart. Okay, now we're going to enter the point 2, 3, and then our line, which is, we'll need to solve for this again. So, once again, just erasing that to give us some more space here. So our equation here is going to be, we're going to solve for this, it's going to be y minus 4 equals negative 2x plus 3. This is pretty simple. Once again, just do solve this first. 2x plus 3, and then add 4 here, add 4 here, get 7. Y equals negative 2x plus 7. And that's going to be our equation. So we're going to put that into the program, like that. And now, as you can see here, we have all this information, but what we want is the slope of the perpendicular line. So y equals 0.5x plus 2. So y is 1/2 x plus 2. So now we're going to graph this. So 0.5x plus 2 is our equation. And then we can graph it. You can just go ahead and use Desmos calculator to find some, if you're on Big Ideas Math like me, where they only let you plot integers, or something similar where, you know, this grid is really dumb, and you can just use Big Ideas Math or something, or sorry, Desmos calculator or something, and find some points that are along these lines. Just plug their equations right into Desmos, and you can just quickly get some points. Alright, so I just used Desmos to quickly find some points that are integers on there. Now we're going to hit check. Oh, I must have plotted that one wrong. But as you can see, it gave you the equation correct. This is just because I'm incredibly stupid. Let me just fix that really quick. So if you look at my paper, you can see I made a very simple mathematical error right here, where I thought this was still 3, and I didn't multiply it by negative 2. See, this is the kind of mistake, these are the kind of mistakes you're going to avoid and save tons of time on by using the my program here. So this is one of many reasons to use it. So now we've got the things right here. So very handy, very helpful. It should work flawlessly, but if there's a bug, you can always report it. Just mark an issue in the GitHub issues section right here. So yeah, that's that. Pretty simple, pretty nifty. Really no reason you wouldn't use it, unless you just want to actually solve all these by yourself, which I honestly can't think of why you would. But yeah, thank you for watching the demo video, and I hope you enjoy using my distance from point to line calculator. Thank you.